Very good morning, students. Myself, SD Sir, Sandesh Deshpande, Mathematics lecturer in SBRPU College. So today I'm continuing the geometric progression problems here. Yesterday, our Mallikarjun Sir, they have stopped up till 17 problems of the exercise 9.3. So I'll be continuing those extra remaining problems of the exercise here. Okay, so let us begin with the next problem, students, of the 9.3 exercise, which is focusing on the geometric progression. So this is the 18th problem now. So what is the 18th problem here? Find the sum to n terms of the sequence. Right? They are asking what here? Find the sum to. They are asking what here? Find the sum to n terms of the sequence. That means find the sum to n terms of the sequence they are asking here, right? Means Sn we should find out. That too what here? They have given the particular sequence in this format here: 8, 88, 888, 8888, and so on. Right? So to find Sn, firstly let us look after the sequence here. What they have given the sequence now? Solution. What they have given the sequence? Given sequence. What is the given sequence here? 8, 88, 888, 8888, so on up to n terms. Why? Why up to n terms? They are asking sum to n terms, right? So on up to n terms. So now let us look at this sequence here, right? This type of problem yesterday they have solved here, right? 7, 77. So they have solved yesterday. So it's a similar problem here. So if we look at the sequence here, the sequence is neither in AP nor in GP, students, right? If you look at this one here, if you take the difference, you'll be getting 80 here. You are getting what here? 800 there. So you are not getting the common difference. If you take the ratio also, 88 by 8, you are getting 11. 888 by 88, you are not getting 11 then. So it is the common ratio is not same here. So it is neither in AP nor in GP. But we have to convert this sequence in the form of GP there. We have particular procedure. We'll be following that procedure here. Okay. So let us move on to solve this problem here. So I have to find sum to n terms. Means I should find Sn there. So as we know, this is the sequence. If I take the sum of this one, what happens now? It looks like in this way here. 8 plus. Why? Because I am taking the sum. 8 plus I should write here. 8 plus 88 plus 888 plus 8888 plus so on up to n terms. Right? So on up to n terms. Right? Now, I told you it is neither in AP or not GP. We have to go with a particular procedure here. What is the procedure? Let's see here first. Let me take 8 common in each and every term then, right? Of this series here. So let me take 8 common students. What happens now? 1 plus 11 plus, if we get common, 111 plus 1111 plus so on up to n terms. Got it? So I took what here? 8 common. So here some adjustments I have to make here. What is the adjustment here? I should multiply 9, I should divide 9. Why? I'll be telling you later then. So just simply multiply 9, divide by 9 to this bracket here, sequence, series. Right? So on n terms. So what I have done the adjustments here? I multiply 9, divide 9. So what I do next step, students? 8, let me keep 8 as it is. This denominator 9, let me keep as it is. I'll be keeping numerator 8, denominator 9, I'll be keeping as it is here. Now what I do, this 9, what is this 9? I'll be multiplying inside the bracket. 9 into 1, what happens? 9. Next, 9 into 11, it becomes 99. Next, 9 into 111, it becomes 999. Now, multiply 9 into this one here, it becomes 9999 plus so on up to n terms. N terms. right? Are you reading this? So I kept 8 divided by 9 as it is. This 9 I multiplied inside here. We obtained like this. Now, with the help of these 999, 999, with the help of this, I can form in the form of GP there. How? Again, I have to make some adjustment here. What is the adjustment? Sn is equal to 8 by 9. So this 9, I'll be expressing it as 10 minus 1. Can we write? Yes, of course. 10 minus 1 is nothing but what here? 9. 99, how do we express? We express 99 as 100 minus 1. Yes or no? 100 minus 1 is nothing but what here? 99. Again, 999, I can write it as 1000 minus 1. 1000 minus 1 is nothing but what here? 999. And again, 10,000 minus 1 is nothing but what here? 9,999. Plus so on up to n terms. So on up to n terms. Now we see students, right? We have made some adjustments here like this. Okay. So Sn is equal to 8 by 9. Now what I do, you will be getting what here? Sum of the difference of the brackets here. What I do now, I'll be taking the two brackets, sum of two brackets. Right? So what I do here, sum of two brackets. What I do here, in each bracket we have the difference of two terms, right? So what I do in the first bracket, I'll be taking the first term of the each brackets here. That is a 10, and here 100, here 1000, here 10,000. So I'll be taking all those things where in the first bracket. With this one, 10. Next plus 100, this one 100 plus next 1000. Right? Whether you're getting this, let me write bigger number. So this is 10, next 100, next 1000, next 10,000, so on up to n terms. So on up to what here? So on up to n terms. Right? 10, this one next 100, next 1000, next will be 10,000, so on up to where? N terms. Next, in the second bracket. In the second bracket, what are the second terms of the each bracket there? Second terms are what here? Minus 1, here what here? Here what? Minus 1, here also minus 1, here also minus 1, here also minus 1. Let me write in the second bracket there. Minus 1, this minus 1, next minus 1, so on up to. Right? This minus 1, second one minus 1, here third bracket minus 1, fourth bracket minus 1, so on up to what here? So on up to n terms. Okay, this is the second bracket. So in the total bracket itself, we made the sum of two brackets, where the first bracket consisting the first term of the each brackets of this one here, and second bracket consisting second term of the each brackets here. Got it now? Now if you look at this first bracket, students, and the main bracket, if you look at this series, it forms what here? GP series, geometric progression series. It is forming here. Why? Just here, if you take the ratio of the second term and by first term and third divided by second, you'll be getting common there. So that is constant there. That is 100 divided by 10 is how much? 10. 1000 divided by 100 is how much here? 10. So you are getting common ratio there. So it forms what here? GP series. For this only we made in this way here. For this purpose, what we did here, we took 8 common. We have adjusted multiply 9, divide 9 there, and we have multiplied 9 inside the thing. So for this purpose only we did in this way here. Got it now? So since it is in the GP series, so A value will be, what is the A value now? First one, A value is 10. What is the common ratio? Second term divided by first term. 100 divided by 10. So 10 ones are 10 tens are. So R is equal to how much now? 10. So R is 10, which is greater than 1. Right? So this is the thing. So A we got now, R we got. Okay, so on p n terms. Now you see, Sn is equal to 8 divided by 9. So now, once let me use this, since it is a series, right? So sum of the terms here, sum of n terms here. So once let me express the formula, students. Let me write, once I have to write the formula of Sn there. Why? Because it is a sum of n terms. I should implement Sn formula. So what is the SN formula of the GP sequence here? A into 1 minus R raised to n divided by 1 minus R. So why I have written this? Because, sorry, I should mention, since R is greater than 1, no students here, R is greater than 1 means this formula changes to what here? This formula changes to what now? In this way. Right? You people know the formulas of SN there. Whenever R is greater than 1, I should use this formula. A times R raised to n minus 1 divided by R minus 1. So once let me use the formula here. Okay. So for this, I am using this formula. Plus, that is plus. Next, for this second bracket, students. For second bracket, now you see. How many terms are there? Totally n terms are there. Now if you add these two things, minus 1, what happens? Minus 1, minus 2. If you add these three things here, minus 1, minus 1, what happens? Minus 3. If you add four terms, minus 1, minus 1, it becomes minus 4. Similarly, now you add up to n terms, what happens? It becomes minus n. Where you are getting this? If you add only two things, minus 1, minus 2. Three things, minus 1, minus 1 is minus 3. Similarly, if you add n terms, means it becomes minus n. Got it now? So, now let me implement all a value, r value inside here. What happens, you see. So, Sn is equal to 8 divided by 9. A, what is A? 10. R, again 10. N, we don't know. Minus 1 divided by R is 10, minus 1. Okay. Plus into minus n. Got it now? So this is the thing. Okay, last step. Further step. What do you have to do? Next further step. So therefore, Sn is equal to, the sum to n terms is equal to 8 by 9 bracket 10 as it is bracket 10 to the power n minus 1 divided by, what is 10 minus 1, students? 9 minus n. So this is the answer, students. So sum to n terms of the given sequence, right? Be careful, students, they will be giving the sequence, but what we have to do? We have to add it, means sum, we have to do the addition there, sum to n terms. That's why I have written plus. Okay, so I took 8 common, multiplied 9, divided 9. So we done all these things to get GP there. I have applied the formula. I got this answer here. Do the simplifications, you will be getting this answer. Got it now? Just take down this problem. Okay, now let us move on for the 19th problem, students. So take down here, find the sum of the products of corresponding terms of the sequences 2, 4, 8, 16, 32 and and 128, 32, 8, 2, 1 by 2. It is also very simple, students, here. Find the sum of products of corresponding terms of the sequences 2, 4, 8, 16, 32 and 128, 32, 8, 2, 1 by 2. Means two sequences they have given here. So what I have to use this two sequences here in such a way that I should add them, means sum means I should add what here, sum of products of corresponding terms of the sequence. Means I should add what here, I should add the products of corresponding terms of the sequences. Corresponding terms of the sequences means what here, first term of the both the sequence I should multiply, second term of the two sequences I should multiply, third term of the two sequences I should multiply, fourth term of the two sequences I should multiply. Similarly, fifth term of the two sequences I should multiply, and at last I should add them. So that's why what they have given here, sum means at last I should add it. Addition of what here? Addition of what? Sum of what? Sum of that to product of. Sum of product of corresponding terms of the sequences. Corresponding terms means first term, second term, third term, fourth term, fifth term. I should multiply them and add it. So in that sense, they have given the question here. Okay. So now what happens, you see students here. What happens, see here, right? Now solution. Write down the given sequences first. Given sequences. So write down what is the given sequences, students here. 2, 4, 8, 16, 32. This is the one of the sequence. And what is the second sequence they have provided? 128, 32, 8, 2, 1 by 2. Got it? So now you see. So they have given the two sequences like this. That each sequence is consisting how many elements? 5 things. 5 terms they are getting here. In each both the sequences we have 5 terms. Right? Now, according to them, according to the question, what I should do? Just see here. So according to the question, what I should do? Find the sum of products of corresponding terms of the sequence. Means I need the required sum here. Let me take required sum. Right? Means they are saying that find the sum of. Yes or no? So that is a required sum here. So that too what here? Find the sum of, right? Addition of. Find the sum of product of. Find the sum of product of what here? Find the sum of products of corresponding terms of the sequences. Corresponding terms of the sequences means what here? First term, I should multiply first term of the both the sequence, I should multiply second term of the both the sequences, and so on here. Means I should multiply first term of the both the sequences. What is the first term of the both the sequences here? 2 and 28. I should multiply them. 2 and 128. Got it? Next what here? Similarly, I should multiply second term of the both the sequences. 4 and 32. 4 into 32. Okay. Plus next, similarly, corresponding third term of the both the sequences. 8 into 8. Next what here? Fourth term of both the sequences. 16 into 2. Next, 32 into 1 by 2. Got it? So this what I have done, you see. According to the statement I have done here. What according to the statement? Sum of means addition of. Okay, addition of what? Sum of product of multiplication of what here? Corresponding terms of the two sequences, given sequences, right? Corresponding first, second, third, fourth, fifth term of the sequences we have done in this way. Got it now? So now what happens here? So required sum. What happens now? Required sum. What happens? Let us multiply here. 2 into 128. It becomes 256. Okay. Next, 4 into 32. 128. Next, 4 into 32 will be 128. 8 8s are 64. Next, 16 2s are 32. Next, here 2 1s are 2 16s are. 32 divided by 2 will be 16. You are getting what here? This is the thing. So now take they are asking required sum here, right? Just simply you add it, students, here. Add it. What happens? Add the things. What happens here? 256 plus 128. 264, 284, 384. 384 plus 64. 388. 448. 448 plus 32. 450, 480. 480 plus 16. 480 plus 16. 496. You are getting what here? 496 as the answer. If you add all these terms, what you are getting the required sum here? 496. Got it now? It is a simple thing. Take down. Students, here you can use, since the terms are only 5, that's why I have added directly, students. If we have more than 5 terms or 6 terms, if we have larger some of the terms, means you can use the formula, right? If you have only 5, you can add directly, or else you can use the formula also, students. For SN formula you can use for this series here. You can do it. So you have to take this A value, and if you take, since it is a GP series, if you take the common ratio, you will be getting R equal to 1 by 2, right? And here N is equal to how much? 5. You can use SN formula also. If you use SN formula also, you will be getting the same answer here. Okay, you can do in that way also, right? Suppose if they ask this one for the 1 mark, you can do in this way here. If suppose they are asking for the 3 marks, right? The same question, if they are asking for the 3 marks, what I have to do? Just write on this one here. Now, what else we have to do for the, if they ask this question for the 3 marks? So here, in this solution, I have not used what here? Any GP formulas here. Yes or no? Whether I have used any GP formulas? No, I haven't. So what I have to do now? Now, let me take this series here. Let me use the GP sequence, right? To get this answer 496 there. Okay, I'll be telling you once again, if they ask for 1 mark, do in this way. If they ask this same question for the 3 mark, now we have to you have to do in different way. Let me do in another way also. Okay, so I hope you have picked on this one here. Now next one. So that is in the same problem I'll be doing in the different way here. Now you see. This is also correct. Next, I am doing in the another way, students. Now you see. If they ask for 3 marks, this is the question. Given sequences, we have to write. So according to them, we did the same thing here. Required sum is what here? Sum of product of corresponding terms of the given 2 sequences. So we made like this. We got the series in this way here. So if we, in this way, if we got series means, let me use the GP formulas. For the GP formula, that too, sum of 5 terms. So I should add out here sum of 5 terms. Right? I have to use SN formula there. So for that purpose, I required A value. What is A value? A value is 256. R. What is R? R is, of course, it is in the GP sequence, right? So 128 divided by 256, right? 128 ones are, 128 twos are. So what is R value? 1 by 2. So R value is how much now? That is R is equal to 1 by 2. Which is less than 1, which is less than 1. And what is N value, students? What is N value? 1, 2, 3, 4, 5. N is equal to 5. Now, required sum. So what I should apply the formula here? Since R is less than 1 means what I should use the formula? A into 1 minus R raised to N divided by 1 minus R. So this is the SN formula for a GP sequence whenever R is less than 1. Now substitute here. What is A value now? Let me substitute A and R in this one here. A is how much here? 256. Bracket. 1 is there add on 1, minus is there add on minus. R. What is R now? 1 by 2. R is what here? R is 1 by 2 to the power N. N is how much here? N is how much? 5 divided by 1 minus r. What is r now? 1 by 2. Now you do the simplification, that's all here. So we have to do the simplification. Required sum, right? Now what happens? 256, let me keep as it is here. 1 minus 1 raised to 5 is 1. 2 raised to 5. What is 2 raised to 5, students? 2 raised to 5 is 32. Okay. Divide by. What is 1 minus half? What is 1 minus half? It is half. Okay. Now again you flip this. 1 by 2. If you flip this, 2 goes to the numerator. Right? Let me do here itself, students. Right? Okay. Let me do up here. So let me write on upside here. So what is the thing here? Required sum. Now this 2 goes to the numerator. 1 by 2 is in the denominator, right? And 2 goes to the numerator. 2 into. Next, what do we have here? 2 into 256 bracket. Got it? It goes to the numerator. 2 into 56 to 256 bracket is a random bracket. Now take the LCM within the bracket. Take the LCM within the bracket. What will be the LCM? LCM will be 32. Cross multiply. 32 ones are 32 minus 1. Here nothing but 1 here. 1 into 1 is 1. Okay. So what happens now? So here let us cancel it here. 2 ones are. 2 how much are? 2 16s are. 16 ones are. 16 16s are. 16 16s are. 256. Right? So simple calculations we are doing, students, here now. So required sum will be 16 into, what is 32 minus 1? 31. So what is this answer here? 16 ones are 16, 1 carry, 16 3 is 48, 48 plus 1, 49. Okay. So 496 is the answer. Got it? What is the answer you got? At last, you got the answer as 496. Yes or no? So this is the another way to solve this problem. Suppose if they asked for 3 marks, in this way you should do it. Right? Suppose this problem only, if they are asking for only 1 mark, here, up till here you should write directly, you should write what here is equal to 496. You can add simply directly there. You can add 5 terms directly, you can write 496 directly. Okay, if they ask for 1 mark, up till here is equal to 496, you should write. If they ask for 3 marks, you have to go through this one way. And also logically, since we are dealing with the GP, so we have used the GP formulas here, right? For the first 5 terms there. Only 5 terms we have, that's why we use this one here. I hope you understood. Just take down this one here. Once again, you should write, or you should write all these things there. Okay, you can pause the video, you can take down the notes. So let me go with the next problem, students, here. 20th problem. Show that the products of the corresponding terms of the sequences AR square, so on to AR raised to n minus 1, and AR square, so on to AR raised to n minus 1 form a GP, form a GP, and and find the common ratio. Find the common ratio. It is also very simple one, students. Here, show that what they are saying here, show that the products of means multiplication, show that the products of corresponding terms of the sequences, they have provided two sequences. What are the two sequences? AR square so on to AR is to n minus 1, and capital AR square so on to capital AR n minus 1. So they have given two sequences. What I should do now? They are saying that I should show, what I should show, that to product of means I should multiply. Product of what? Product of corresponding terms of the sequences. Corresponding terms of the sequences means particularly first term, second term, third term of the both the sequences I should multiply. Product of means multiplication of first term of the two sequences, similarly second terms of the two sequences, similarly third term of the two sequences, so on to nth term of the two sequences I should multiply. So when I do this, again I am getting one of the sequence there. Okay. Next, and also after getting one of the sequences, for that particular sequence, you have to find the common ratio there. Okay. Now let us do this one. Now let us write the given two sequences, students. Here solution. What are the given two sequences? Given sequences. Mention first what they have provided you. So what they have given: AR square, so on up to AR raised to n minus 1. This is the first sequence they have provided. And what is the second sequence they have provided here? Capital AR square, so on up to capital AR raised to n minus 1. Right? So if you see all these things, in the first sequence they have given n terms, in the second sequence also they have given n terms. Now what I should do? What they are saying that product of corresponding two sequences, they have given two sequences. If I multiply these two sequences of each term there, again it forms what here GP. So that I should show you. Now you see. Now product of corresponding terms of the given two sequences will be. Now let me do here. Product of what they are asking here. Product of corresponding terms of the given two sequences will be what now? Let us multiply. Let us multiply. Same thing we have here. Just multiply the each first term then. A into A. What happens? A. Now we are obtaining another sequence here now. We are getting another sequence. That too, what here the product of corresponding terms of two sequences now. AR into AR. Small AR into capital AR. We are getting one more second term. This one here. Second term, that too product of second terms of the two sequences. Next, what will be the third term? We are getting, if we multiply the corresponding term of the two sequences there, AR square into capital AR square. Yes or no? Similarly, what will be the last term of this sequence here? Last term, AR raised to n minus 1 into capital AR raised to n minus 1. So we got one more sequence according to them. What they have told here, product of same thing, product of corresponding terms of the given two sequences will be what now? So this is another sequence we got according to them. So whether it forms GP, let's check it out. Whether it forms, they are saying that show that it forms. This sequence forms GP. They are saying this sequence what we did now, it forms GP. They are saying here. Let us show. So here, what is to show it is in GP? What we should do? I should show that it exists common ratio there, right? If it exists common ratio, then I can say that this sequence will be what here in GP sequence, right? So now here, what is the second term divided by first term of this sequence, right? What is the second term divided by first term of the sequence? What is the second term now here? This is the second term. AR, capital AR, right? Divided by first term. What is the first term? A, capital A. Now cancel it. What happens here? Small a get cancels. Capital A get cancels. What remains here? Small r, capital R remains here. Now let us focus on the again one more ratio. Let me take to confirm that whether it is in GP or not. Now next third term divided by second term. What is the third term, students? Third term is AR square, capital AR square, divided by. What is the second term? Third term by second term. AR, capital AR. Right? Now what get cancels here? A get cancels. One time of small r get cancels. It is actually r square. One time of r get cancels. One r remains in the numerator. A get cancels, capital A get cancels. Here capital R, one time of capital R get cancels in the numerator. So what is left out here? R get cancels, one small r remains here. Here one capital R get cancels, capital R remains here. Here A get cancels, small a get cancels. So what remains here? Common ratio R. Check it out whether both are same. Yes. Second term by first term is small r into capital R. Third term by second term is again we get small r into capital R. If we look these two things, we have the common ratio. Means I can guess, I can say that confirmly. I say that. So the given sequence is in what here? GP. Got it now? Why? Because we seen in this way here. So this is how we judge whether given sequence is GP or not. So we are getting this common ratio, right, as R into R. So we can conclude that it is in GP sequence. So therefore, so the given so the product of the product of right product of corresponding so the product of corresponding terms of two sequences. So the product of terms of the two sequences. What is the product of corresponding terms of two sequences? This one. This sequences is this one here, right? Is in GP. Is in GP. Yes or no? And what is show that they are in GP? They are saying yes, of course. We shown here it is in GP. And what they are saying here? Find the common ratio. And what is the common ratio we got here? This is the common ratio itself. What we got the common ratio? Small r into capital R. And common ratio is small r into capital R. Got it now? So this is the common ratio, students. They are told to find common ratio. We found here, that is small r into capital R. And to form this as GP, we did in this way. You should mention here. At last conclusion, you should mention. So this sequence. What is this sequence actually? The product of corresponding terms of the given two sequences. Is in it forms what now? GP. How? From this. Okay. So try that. Now let us move on for the 21st problem, students. So 21st problem. Find four numbers forming a geometric progression, forming a GP in which the third term is greater than the first term by 9, comma, the second term is greater than fourth term by 18. So this is the question problem. This is the question of the 21 problem here. What they are saying, students, here, just look it out here. Find four numbers, they are saying. Find four numbers. Okay, let me find out four numbers. Okay, what they are saying further there, find four numbers forming, means these four numbers forming a GP. Okay, these four numbers forming a GP in which the third term is greater than the first term by 9 and second term is greater than the fourth term by 18. Means they have given some hint here. They are providing us some hint. What is the hint here? The third term is greater than the first term by 9. One more hint they have provided. Second term is greater than fourth term by 18. So the two hints they have provided. With the help of these two hints, I should find what here? Four numbers, which forms what here? GP. Okay. So now let us move on for the solution here. Right? Find four numbers they are saying here. So now let me consider, let the four numbers be. Let the four numbers be. A1 is equal to A, A2 is equal to AR, A3 is equal to AR square, and A4 is equal to AR cube. So I have assumed these four numbers like this here. So why you have assumed like this? Because I should take only in this way, because they are saying that it forms GP. I have to find four numbers forming what here? GP. Whether these four numbers forms GP? Yes. So in that way only I took the assumption here. Let the four numbers be A, AR, AR square, and AR cube, which forms GP, right? Which forms, right on here, which forms GP. Let the four numbers be A1, A2, A3, A4, which forms GP. Okay, now let us find all the four numbers. Let me write down the given hints. What they have given hints here, in which the third term, how do we express third term in what here? A3. Third term is greater than the first term. What is the first term in what here? A1. Third term is greater than the first term by how much? By 9. Greater than the first term by 9 means what here? It's a more value. Yes or no? It has a larger quantity. So A3 is greater than A1 by how much here? By how much? 9. Means we express this statement in the equation form. That is A3 is equal to A1 plus 9. Third term is greater than first term by how much? 9. Right? Given, let me write here. Given. And one more they have provided here. One more what they have provided? Second term. Second term is what here? A2. Second term is greater than the fourth term. How do we write fourth term? A4. A2 is, that is second term is greater than the fourth term by how much? By 18. Means 18 is, little bit, this is the larger quantity, students. A2 is what here? Fourth term is greater than the fourth term by how much? 18. 18 is the difference between among these two things there. Okay. So these are the two given hints. with the help of these two given ends, I have to find A1, A2, A3, A4, right? Now you see, students, what they have given hint, these two things are the given hint. Since A3 is what here? A3 is what? A1 plus 9, right? How do we express A3? This one. What we assumed here? A r square is equal to A1. What is A1? A we have assumed. A1 as A we have assumed here. Plus 9. What I do? I send this A towards left side. A r square minus A is equal to 9. What is common among these two things? A is common. R square minus 1 remains. Okay. Now let me call it as equation 1, students. Let me call it as equation 1. Similarly, and also what they have provided? A2 is equal to A4 plus 18. Yes or no? A2, how do we express A2? What we have assumed there? A2 as A into R. A4, what we have assumed here? A4 as AR cube plus 18. Now send this AR cube to the left side here. AR minus AR cube is equal to 18. Got it now? So what is common in both the things here? What is common? AR is common. Agree? AR is common in both the things. If you take AR outside, it becomes 1. AR into 1, AR. Minus is there, red on minus. A you took outside, R you took outside. What remains? R square you are getting is equal to 18. Right? So now it is 1 minus R square. Here we are getting R square minus 1. So let us match with that. So for matching purpose, what I do here, purposely I will be taking minus common, students. Let me take minus common purposely. What happens now? AR bracket R square minus 1. Agree? If I take minus common in this bracket, what happens? It shifts like this, R square minus 1. Generally, what we say, A minus B, it can be written as minus of B minus A. A minus B is written as minus of B minus A. Why? Minus into plus B, minus B, minus into minus A, plus A. Got it? So in this sense, what I have done, 1 minus R square is written as minus R square minus 1. Okay, got it now? So why I have done like this? Because here also we have R square minus 1. So in that way I have changed like this. Okay, is equal to 18. Is equal to 18. Now, let me call it as equation 2. Let me call it as equation 2 then. So now to find first 4 terms, what I do here, divide equation 2 by equation 1. Right? Sir, why you are doing like this? Because I have to find first 4 terms. In the first 4 terms, I required A as well as R. And if you see on first 4 terms, I required A value and R value. So to get A value and R value, I should use both the things. So how I am using both the things? In this way here. Divide equation 2 by equation 1. You can divide equation 1 divided by equation 2 there. No problem. If you do equation 1 divided by equation 2, no problem. So let me take equation 2 first. What is the equation 2? LHS of the equation 2. What is the LHS of the equation 2? AR R square minus 1 divide by, here LHS of the equation 1, A R square minus 1 is equal to RHS of the equation 2 first, 18 divided by LHS of the equation first, sorry, RHS of the equation 2 divided by RHS of the equation 1, that is 9. See what get cancels, students, here? A get cancels, R square minus 1 get cancels. Here 9 ones are, 9 twos are. What remains here? Minus R remains, minus R. This get cancels, is equal to 2 by 1 is 2. So R is equal to how much here? Minus 2. R is how much? Minus 2. Got it now? You got R value. So to find first 4 terms, only R is required, means not possible to get 4 terms there. I have to get A value also there. Right? R we got. Now let us find A value. How do we find A value? Just simply substitute R equal to minus 2 in any one of the equation. Either in one equation you can substitute R value, or in 2. So substitute r equal to minus 2 in the equation 1. You'll be getting a value there. So let me write here friends. So put r equal to minus 2 in equation 1. So 1 implies what happens? A r square minus 1 is equal to 9, right? This is equation 1. A bracket, this is A bracket, r is what now? R is minus 2. R is what now? Minus 2 whole square minus 1 is equal to 9. A. What is minus 2 square? Plus 4. Minus square plus 2 square 4 minus 1 is equal to 9. What is 4 minus 1? 3. 3 into A, 3A is equal to 9. So A equal to how much? 3. Right? 9 by 3. This implies A equal to 9 by 3. 3 ones are 3 3s. So A equal to how much here? 3. Got it now? A you got, R you got. So you can find these 4 terms here. Right? They are told to find 4 terms. So therefore 4 terms are 4 numbers. 4 numbers or 4 terms, right? Are A1. What we took A1 here? A1 is A. What is A? A is 3. Right? Next. A2. A2 what we took here? A2. A2 is AR. What is A? 3. R what we have? Minus 2. What happens? Minus 6. Next. A3. A3 what we took here? AR square. A3 is what here? AR square. A is 3. R is minus 2 square. 3 into minus 2 square is 4. 3 4s are 12. Okay. Next. Fourth one. A4. A4 is what now? A4 is AR cube. A is how much? 3. R is what here? Minus 2 whole cube. So what happens? 3 into minus 2 cube will be minus 8. Minus to the power odd number will be minus. 2 cube is 8. What happens? 8 is 24. So these are the first 4 terms. 3 minus 6, 12 minus 24. Which forms out here? GP. Got it now? Okay, let us move on for the next problem, students here. If 22nd problem. If the pth term, qth term and rth terms of a GP are A, B and C respectively. Full stop. Prove that A to the power Q minus R into B to the power R minus P into C to the power P minus Q is equal to 1. I should prove this one. A to the power Q minus R, B to the power R minus P, C to the power P minus Q is equal to 1. I should prove here. Now you see, students. So what they have provided here, if P, Q, rth terms of the GP are ABC, this is the thing they have provided. Then, if this is the case, then prove that this one here. Okay, so let me write down here. What they have provided? Given what? Pth term. Nth term, how we denote? Nth term we denote it as an. Similarly, pth term, how we denote here? AP, a small p. Nth term is a small n, pth term will be a small p. Pth term, qth term, rth term, they have brought out here. Pth term, qth term, rth term is small a, b and c. They have already given here already, right? Pth term, qth term, rth term of the gp is given as a, b, c respectively. Then prove that this one here. So to prove this one, now you see what is the an formula. What is the an formula, students? A r is to n minus 1 for the gp there. Yes or no? So now let me write a r to the power p minus 1. So an is what here? A r is to n minus 1. In the same sense, AP will be writing it as AR to the power P minus 1. Sir, why you are writing a capital A and capital R? To avoid confusion as like this here. They have provided small a, right? If I write AR is to n minus 1, you people are doing what here? Cancellation here. You should not do the cancellation. This A is different, this A is different. It's the value of AP term there. Got it? So for that purpose, what I'm doing here, I'm taking capital R, capital A and capital R to avoid confusion. Got it now? So AP is what now? In this form itself, AN is AR is to n minus 1, AP will be AR to the power P minus 1 is equal to A. Similarly here also, AQ will be what here? AR to the power Q minus 1 is equal to B. AR, what will be the AR now? A capital R to the power R minus 1 is equal to C. So again, same thing. Instead of A, we'll be writing capital A. Instead of R, I'll be writing capital R here. Why? Because to avoid the confusion. If you write like this, AR to the power R minus 1, you people are knowing that these two things are different actually. But you people think that both are same there. So to avoid confusion, so what I have done, like this I have written here. These two things are not same. Okay, so that's why I have written capital A, capital R here. Got it now? So this is the formula. So this is the given cases. So let me prove this. So to prove this, let me take LHS. Let me take LHS. What is LHS here? Consider LHS. What is LHS? LHS is A to the power Q minus R into B to the power R minus P into C to the power P minus Q. Let me consider it as LHS here. So what is A? What is A actually? A is what now? Like this. Capital A R to the power P minus 1 whole to the power Q minus R. Okay. What is B actually? What is B? It is into A R is to Q minus 1 into R minus P. B is what here? This one I have written. To the power what here? I minus. B is this one. To the power is R minus P. Into C. What is C? C is A R to the power R minus 1. This is C. To the power what here? To the power what we have? P minus Q. So in this LHS, I have replaced A value, B value, C value here in the LHS. Now, as we know, what be AB whole raised to n? A raised to n, B raised to n by the laws of indices. AB whole square, you are writing A square, B square. In the same sense, AB whole square will be A square, B square. Means A to the power this one, R to the power this one. I should split it up. Okay, so for this thing, I'll be splitting like this here. So LHS, what happens now? AB whole square will be written as A square B square. That means A to the power Q minus R, R to the power P minus 1 whole to the power Q minus R. Right? I hope you understood. Same thing, in the same sense, what we have done for this one, same thing we have to do. A to the power R minus P and next R to the power Q minus 1 to the power of here R minus P. Similarly for this also, A to the power P minus Q, AB whole square means A square B square means A to the power P minus Q, and next R to the power R minus 1 to the power of here P minus Q. Got it? Right? So I have applied the laws of indices property like this here. Now you see, students, what happens you see. a to the power q minus r. Let me keep as it is. Now you see, again we have the property a raised to m whole raised to n. What is a raised to m whole raised to n? A raised to m into n. Means powers I should multiply. Keeping base as it is, powers I should multiply. Here also, keeping r, base r as it is, I should multiply the powers. What is the powers here? P minus 1 into q minus r. Similarly, this a to the power r minus p, let me keep as it is. Here also, let me apply the same laws of indices property. Keeping r as it is, let me multiply the powers here. What is the powers? Q minus 1 into r minus p. A to the power p minus q, let me keep as it is. And this also, same thing. Keeping base r as it is, I am applying this one. First, I should multiply r minus 1 into p minus q. Right? So now, again we have the property, students. A to the power m, a to the power n is nothing but what here? A to the power m plus n. If base is same, in the multiplication, I should add the powers here. So now you see, a here a also is there. Here also we have a. Bases are same here. So if base is same in the multiplication, what I should do? I should add the powers. So let me add the powers of the base a. What happens? LHS is equal to a to the power. I should add the powers q minus r plus r minus p plus p minus q. Have you got this one here? Here a base is same. I am adding the powers, students. Why? According to the laws of indices. Okay. Next, similarly, again I am applying like this here. Here r, here also r, here also r. The base is same. So base is same means what we have to do? I should add the powers. So r to the power. What is the power now? This one. P minus 1 into q minus r plus. I should add this also. Q minus 1 into r minus p plus this one. R minus 1 into p minus q. Okay. Okay. So what I have used here? I have used this laws of indices. R base is same. I have added the powers. That's all. Okay. Now let us do the simplification. Now let me split the bracket, students. Let me split the bracket. If you split the bracket, it becomes q minus r. Split the bracket r minus p. Split the bracket p minus q. Similarly here also r to the power. Let me split the bracket. To split the bracket, I have to multiply the two brackets here. To multiply two brackets, here two terms are there, here also two terms. Totally four terms will be getting p into q, pq, p into minus r, minus pr. I am multiplying the two brackets. P into q, pq, p into minus r, minus pr, minus 1 into q, minus and minus r, plus r. Okay. So if I multiply two brackets, you will be getting four terms like this. Plus q into r, qr. Again, I have to multiply these two things. Q into r, qr, q into minus p, minus qp. Right? Next, minus 1 into r, minus r. Right? Next, minus 1 into minus p, plus p. Right? Next, plus. Again, for the multiplication of two brackets here. R into p, rp. R into minus q, minus rq. Minus 1 into p, minus p. Minus 1 into minus q, plus q. So what I have done here, I have multiplied the two brackets and I have separated the brackets here. Got it now? I have multiplied two brackets. So in each of the multiplication of two brackets, you are getting four terms. First four terms, next four terms, and other four terms there. Got it? So we have 12 terms. Now if you look at all these things here minus p plus p get cancels. Here plus q minus q get cancels. Minus r plus r get cancels. What remains here to the power here? A to the power 0 remains. Here r to the power. If you see plus pq minus qp plus pq minus qp, both are same but in the different direction, plus and minus there. Different sign, plus sign, minus sign we have, that to same quantity it vanishes. Means 2 minus 2 will be 0 there. In that form, pq minus qp will be 0. So now what happens? Minus pr plus rp, both get cancels, plus pr minus pr. Okay. Similarly, minus q plus q get cancels, plus r minus r get cancels, plus QR minus RQ get cancels. Plus P minus P get cancels. So all are cancelling. All are cancelling means what remains? Nothing remains. Nothing remains means 0. So LHS. What is A raised to 0? 1. Any non-zero quantity to the power 0 will be what here? 1. Non-zero quantity to the power 0 will be 1. So A to the power 0 is 1. R to the power 0 is also 1. 1 into 1 is nothing but what here? 1. So which is RHS. Whether we prove it as 1 here, I have to prove it is equal to 1. So we proved it. So these are all the things of the GP problems. Let me continue the problems tomorrow there. Until then, you practice at home. Thank you. Have a nice day.